usually want this kind of sine wave so that it perform well. But if your power is like this one, so you can expect that your equipment will become a little bit hotter, okay? And its performance, if your performance is like 95%, if you have a power quality problem, it becomes 80%. And the lifespan of your equipment, it will not last long. It becomes shorter, okay? So we have a different, kaya most common power disturbance which we are encountering in our system. Here we have a normal voltage. Normal voltage have a sine wave which is the same for almost of the cycle. But here, if we have a voltage dip or voltage sag, you can see here that the sine wave or the wave is not the same. Okay? For momentary interruption, if you have a recorder, you will record that in some part of the sine wave don't have any kind of wave here. So it means there's interruption. Okay, and we have also swell. Swell means it's a short duration of voltage, like over voltage, like the opposite of the sag, it's swell. And also we call it transient. Transient, usually we encounter like in a distribution system, you have an overhead line and suddenly a branch of tree suddenly biglang dumikit or touch the line and you have some transient. Or sometimes we have a power transformer or generator that you have started, you have transient, okay? And those transient have very small time. See, if we have here a one cycle here, 60 hertz. So the 60 hertz is 16.66 milliseconds. So if you look at the transient, it's almost nothing, okay? So sometimes we don't see or transient, we don't know that there's transient happen unless you have a recorder that can record transient. But for starting motor, we call it a transient because there is exciting current. So if you have start big motors, suddenly your current will go up, but for a certain time only. But we need that kind of starting because we will set our protective relays for that kind of we call it exciting current or inrush current. Here we have the harmonic distortion. Nowadays, most of our motors, because of we need to install BFD for precision, like in a manufacturing plant or industrial plant, you have a BFD. So BFD, we know that it is giving harmonics. And we know also that 5 and 7 is the harmonic content of most of the BFD. So if we have a BFD in our system, we expect that there's harmonic in the system. So we have to mitigate that kind of harmonics. We have also notches. So notches, you can see in my sine wave that there's a repetition in the upper, in the positive and the negative peak before going to peak voltage. So there's a repetitive part. We have also a voltage fluctuation. So voltage fluctuation, uh, there are many kinds of voltage fluctuation. Like if you start a big motors, suddenly your voltage goes down. Okay, that's why uh, we have a capacitor bank to correct that voltage. Capacitor bank in the first place is not only a power factor correction, it is also a voltage regulation. But if you have a over voltage, we don't need capacitor bank, but we need a shunt reactor. Okay, so shunt reactor will be used if you have a over voltage and under voltage or like voltage fluctuation. Usually we use a capacitor bank. And also we have here the frequency deviation. So frequency deviation, uh, remember we have an outage here in North Luzon that most of the area in North Luzon have power interruption. This was due to a frequency deviation. So when the Swal power plant shut down, we know that Swal power plant is a big generating plant. I think it is 1,200 megawatt. When the power plant of Swal shut down, then the frequency goes down. And then some of the power generation also, because of frequency deviation, some of them shut down also. Okay, but we have a load shedding. So if you know how to load shed the complete outage, we can avoid that complete outage. So all of these are the most common power disturbance that we encounter every day in our industrial plants, even our power plants, even in our homes or in commercial establishment, all. Here, how can we measure a power quality? If you don't have a measuring equipment, you cannot. So you need to have a power quality measurement or device. There's a lot of power measurement devices in the market you can choose. But in our part, we have our own and we supply this power quality, which is power sight, PQA. The difference of this one, we can measure up to 5 kilohertz. Okay, remember that in an IEEE, it stated there that the limits to measure is less than 9 kilohertz. Those standard PQA in the market, mostly they have the until 51 harmonic. So if you multiply the 50 by 60 is only 3 kilohertz. Okay, so this power site is up to 5 kilohertz. Again, measurement of power quality usually done online, and it is so dangerous. So if you see the screen, okay, we have a connection city here. We have a clamp, okay. We have also a clamp which is flexible, and we have a clamp through the voltage. So how do you measure or how do you install a power quality measurement in the field? First, you need to have a safety, okay? because if you don't have the safety, maybe you will be electrocuted. So here we have a gloves. Those gloves, usually the rated kV is up to 1 kV for low voltage, but most of the power quality we measure at the low voltage side. But sometimes they ask me, how can we measure power quality in the high voltage or the medium voltage? We can measure. We can measure through the current transformer and the voltage transformer. Okay, and how can we record? Okay, we have a recording time for the power quality. Sometimes we do a spot measurement. If we say spot measurement, on that time, you can read what is your power quality indication. But if your customer want to be 24 hours or 1 week, it can. As long as you have your device can have a much longer data or have a ibig sabihin, mas malaki yung gigabytes of your hard drive of your power quality device, so it can measure. So what is the difference of the spot measurement for the long measurement? Sometimes our operation in the plants is not continuous. So we have a motor that start only during daytime and during nighttime it is stopped. So if you only do a spot measurement, you cannot trend. So my recommendation is 24 hours or up to 1 week is the best measurement to be conducted in your system. Okay, again, you need to have a caution tag or only the qualified technician or engineer to perform the power quality measurement. Okay, sometimes if the plant is so strict, they will implement the whole body PPE because of arc flash. Remember, this is live. Okay, so after conducting a measurement, we have a result. So if we have a customer and it say, oh, can you conduct a measurement? So once we have conduct a measurement, we need to have some analysis. We don't just give the result to the customer because sometimes our customer don't have time to study or sometimes they don't have the knowledge how to interpret. So as a technician or engineer who conduct the measurement, they should have knowledge how to measure or how to analyze. Because if you don't have the knowledge to analyze, the result, it will become rubbish. I mean, if you submitted without analysis, it's not good. So here we have some sample power quality result. This example is a agitator motor with BFD. So if we know that it's BFD in our mind, we know that is a distortion. So if we look here, we have the current and the voltage. Look at my graph here. See, this is my sine wave. To complete the cycle, this is per cycle, and this is to complete the whole cycle, this half cycle. So it is not pure sine wave. Why? Because of the harmonic present in the BFD. In the right side, we have a voltage waveform. Why the voltage is not distorted as this current? Most of the harmonics, because voltage is coming from the utility, so most of the harmonics is come from the customer. most of their BFD, so that if you have a current harmonic and your voltage also become distorted, but not that big, okay? But if you have a lot of voltage or VFD in your system, it will affect your voltage also, and it become problem because harmonics goes up from your plant, okay? Because you have only one line. So if Meralco providing a good power in your plants or power supply, and you are producing harmonics, those harmonics go back to Meralco. That's why Meralco is complaining. Here in the Philippines, sometimes it is not strict, but if you go like in Europe, they have penalized to those customer that very high harmonic content. Okay, so again, I said here, it's a BFD, so what's to expect? Okay, we have a graph. Here we have a harmonic in a voltage graph. So a BFD known to have a fifth and 7 dominant order, so 5 and 7. And we can see here visually in the current harmonics graph. But sometimes we don't, we cannot analyze by total harmonic distortion. We need to analyze the individual current, not this graph, not in percent, sorry, not in percent, but in current, okay? Because sometimes if you measure, you have very high total harmonic distortion, but your current is so small, 0.5 ampere or 1 ampere. So it's better to look for the current harmonics like this one. See here, almost 150, it's so high, okay? That's why there's effect in the voltage. See the 5 and 7 here, okay? So most of the plants, the problem is the VFD. That's why we have to mitigate. How can we mitigate those harmonics? Okay, in the market again, there's so many kind of manufacturer providing passive filter, active filter, etc., and so on. Okay, but for you yourself, if you have your own plant, you need to decide which good for you. Okay, so what are the mitigation? Okay, we have here mitigation that we use. We are using or supplying the mirrors power. We have the, call it active power filters, the static compensators, the energy storage, and so on. See, most of these are power electronics, which means if you have a distorted waveform, this system can introduce also a distorted waveform in your system in the opposite direction in order the summation will have a good sine wave, okay? But sometimes the installation is difficult because those equipment is electronic and they should have installed in a place when it is air conditioning and it is a good place, because if you install just outside, your active filter will become a problem too. Okay, so there's a lot of mitigation, not only this kind of devices. We have also a power capacitor bank with reactor. It's the cheapest way, but sometimes using capacitor bank could not perfectly erase all those kind of harmonic in your system because of the time. This mitigation technique is almost real times. almost real. But for capacitor bank, sometimes if you have a 50 step or a 5 step and you have a delay. So if you have a, a motor or a device that the switching is too fast, so you cannot correct. Okay, that's why active power filter is the best solution for those uh, power industrial plants that have a very dynamic loads. Okay, I think my presentation is so short because I don't like, or I don't want to discuss all of those things by detail because we have a full course seminar to tackle all of this. So this is only a preview and just a overview of what you are expecting for the full course. Thank you.
Okay, there you have it. Thank you, Engineer Edward. Let me just post something on the screen. Let me share my screen now. Okay, there you have it. All right, so to okay, just an announcement to everyone, to our participants out there. This coffee break webinar sessions, this idea has been designed, has been created para it's our way, Pamav Tech's way to at least provide still continuous learning sa ating mga continuous technical learning sa ating mga engineers out there. And we hope that this webinar series will at least help you in your current practice. And for our participants, this is the schedule of our coffee break webinar sessions. You might want to still join us. No, these are the schedule. And yung sinasabi ni Engineer Edward kanina, oh, by the way, let me just flash on the screen as well. This coming Friday, our very own engineer, Peñalosa, will be the one speaking about electrical safety for workplace. Again, same time, 3 o'clock this Friday. And back to the full course webinar, it's already available. The schedule is out there in our calendar. Our sales supervisor, Ashley, will be flashing on the screen or on the chat box the link for you to register and reserve your seats. Again, these are our full course webinars that are available until September. Now, let me just go ahead and proceed with our Q&A. Engineer Edward, ready ka na ba? Okay. Here, we have a question from Engineer Eric. Yung mga early bird natin kanina, nakita ko si Engineer Eric. Isn't it that the power quality standard is EN 50160? Are there any difference with IEEE 1159?
I think that, okay, I think that EN is a German standard. I don't know, but because for European, IEC is the main standard they are using.
Okay.
I don't know exactly that EN.
So EN 50160 is more of the German thing. Is that so, Engineer Edward?
I don't know exactly.
Okay.
Yes.
All right. So there you go. We also have one question here. What are the different power quality tests to ensure reliability in electrical system?
Power quality tests.
Yes. What are the different power quality tests to ensure reliability in electrical system?
Okay. So if you are looking for reliable system, usually we do a measurement. If you have a measuring device, but that measuring device can do many things, like it can measure voltage, the current, the harmonics, the power, and so on. As long as you have all the data that your device can measure, and you can analyze what will happen, what is happening into your system, then you will see, or you can, you have your own program how to make your like maintenance or your forecasting to correct that kind of problems. So in short, they should have a device or measuring device that can measure all of the data needed. The one that I uh, as I say.
Okay, thank you, Engineer Edward. I hope that answers your question, Engineer Roder. Do we still have other questions? Maybe you can just raise your hand or type it on the chat box before we finally end our webinar. If none, do you have another questions? What about from the panelists? Do you have questions for Engineer Edward? Okay, thank you. Sabi daw po ni Engineer Roder, thank you. Okay, this time from Engineer Eric. I use the latest Fluke 438 PQA and the standard it uses is EN 50160. Will it have difference with your PQA?
I think it's the same. Because if you look into this, most of the standards, IEEE and IEC, if you dissect, they are the same, because they are also looking for the like voltage dip, the sag swell, but mostly IEC, they call it electromagnetic compatibility. Like if you have equipment that emits some electromagnetic, it will go to your power lines, and those have also a frequency. So they are the same. Sometimes it depends where you are. Here, if you are in the Philippines, you can use all. But if you are in the US, mostly they're using IEEE. But if you are in Europe, yeah, they will use their standard also. Even in the Japan or Chinese, they have their own standard. But most of them have their own, and they are almost the same.
Okay, same standard, I guess. Thank you, Engineer Ed. We have a question here from Engineer Juniel. How to address mismatch of voltage for load and supply?
Again, ma'am, hindi ko naintindihan.
How to address
yung
mismatch daw po. Mismatch of voltage for load and supply.
So ibig sabihin, your supply voltage and yung load is different? Parang ganun yung ginagawa niya eh.
I guess that is the question. Are we correct, Engineer Juniel? You can write on the chat box if tama yung pagkakaintindi namin. There's a mismatch of voltage for load and supply. And how are we going to address it?
You mean your voltage, usually voltage provided by the utility. Let's say we have a Meralco. Meralco, the standard is 34.5 kV, and step down if for the homes is 220 or 230 volts, or if you are industrial, you have 480. Okay, so the voltage going to your industrial plant, if you have your own transformer, let's say, yeah, you have said 400 volts. 400 volts secondary and 300 volts for motor. So you have the secondary voltage in your transformer, which is 400 volts. And you measure the voltage going to your motor is 380. Is that you are asking? Can you unmute yourself, Juniel? Pwede ba? Pwedeng ano ka para mas maintindihan natin?
Let me just double check.
Okay.
Oh, there you go. All right. Engineer, you're unmuted na po.
Can you speak, Juniel? Pwede ba? Explain mo lang yung ibig sabihin niya. Kasi pwedeng mababa siya if you have a long cables. Let's say from your transformer secondary is 400 volts. And you will supplying a motors far from your transformer, then it will have a voltage. So what mean with designs for supply and then 380 volts template? Ah, okay. So your motor nameplate is 380 volts and your supply voltage is 400. Sometimes yan yung nagiging problema sa atin. Kasi we have integrated or we have mixed the standard for US and the European. Okay? So, but I think that 400 and 380 volts is still good in our experience. Okay? Because that 400 volts, it's your secondary voltage, but if it is going to your loads, sometimes it's go down, especially if you have a lot of loads. But if you, in the time that you have a light load, sometimes it's go up. So you need to have a tolerance. If your nameplate 380 volts is plus or minus, let's say 5% or 10%, it's good. So it depends of your design. So if your motor design 380 volts nameplate with its tolerance of plus or minus 5%, if within that range, it is good. But if it is not, then it will become problem to your motor.
As an addition to that, sir, because the load side is 380 volts and your power supply is 400, right? Or
Yes,
yeah, 400 volts. So there is a difference with the 20 volts. It can cause, because your power is constant, it can cause higher current. So there is a additional heating effect for that. So to mitigate that issue, you can install a voltage stabilizer specific for the voltage rating of your equipment. Voltage stabilizer, sir, we can put plus minus 1% variation in the output. No? The input natin is 400 volts. Output is 380 plus minus 1%. We can do that. Voltage stabilizer. We have you can search the iVolt, no, in the
Solotech
website. We can mitigate that issue.
Okay. I hope that answer your questions, Engineer. Yan. Full force tayo kay Engineer Ed and Engineer Alex. One last question though. All right. This is from Engineer Chris. When is the best time to install active filters, etc.? During design, construction, or operation phase? Since these active filters, etc., would incur additional cost and space in the electrical rooms.
I will answer first, Lex. It is the best time to install that active filter when your plant is already in operation. Okay? Because in the design, it is only design, but we don't know how the equipment behave. Like if you have a lot of equipment that provide harmonics, it's not easy. We can do a analysis like running the harmonic analysis in the software, but that is only a simulation. So in my opinion and experience, we usually install during operation. Lex, you can add.
No more to add, sir.
Okay.
Okay, there you go. All right, meron tayong follow-up question kay Engineer Juniel. Is series reactor can also protect the system during voltage abnormalities as you mentioned?
Sagutin mo Lex. Kaya mo yan. Reactor.
Can you repeat, Kat?
Is series reactor can also protect the system during voltage abnormalities as you mentioned?
The series reactor can protect your system for a sudden rise of current. No? If your voltage suddenly drop, your power is constant, there is a sudden rise of current. That is why if you encounter sags, no, voltage sags, there is a spike in the current, the reactor can mitigate that or can counter that spike. So the reactor can protect the equipment. That's why some BFDs have the AC choke,
Yes.
no, or the reactors.
Okay, thank you, Engineer Alex. One last, would it be possible to have isa pang hirit? From Engineer Therese Marie. Kinsa may mga contractor mo taod o mga harmonics filters
Alex yan.
mo study?
Kami.
Lex.
Kami mutaod.
Okay, go ahead. Okay, go.
Yeah. Pwede kami mutaod og harmonics filter ha. If you have harmonics problems, we can supply the harmonics filter. We can also install. Okay, but before we will recommend a harmonics filter, we need to have PQ analysis first. Pwede may mutaod.
So, kontakin mo siya, Lex.
Okay, yeah, kontakin daw namin ikaw, Engineer Therese. Please give us your email so Engineer Alex can contact you, no? So there you have it. Thank you so much.
Okay.
Thank you, engineers, for a very wonderful, informative talk this afternoon. And again, I just wanna inform our participants, should you want to have extensive yung full course webinars, please visit our website, or you can just click the link provided on the chat box for the for our schedule of full course programs. And of course, don't also forget this Friday and other consecutive Fridays yung ating mga webinar series like what we do. Okay, please also attend that. Engineer Edward, Engineer Alex, do you have anything last words to say before we finally end the webinar?
So again, thank you everyone for listening and joining this training webinar, a coffee break webinar. So don't forget to put your mask. So I will put in now my own. Okay, so bye.
Okay, Engineer Alex, you have anything to say? May pahabol si Engineer
There is some question here
yeah.
Sige.
from Therese. Pwede ba magpa-study diri? Pwede po, pwede.
Pwede.
Ang bayad, ito kung pila ang bayad, bibigyan kita ng estimated cost. We are offering 10,000 per point, no? Then mobilization. Mobilization kung saan location kayo, magbabari yung mobilization cost. Okay?
Okay. there you have it. Again, engineers, participants, everyone, maraming salamat po. And you're able to join us this wonderful afternoon. Hope this short webinar has given you an insight, or this will help you in your current practice. So again, thank you and keep safe po. Bye-bye po.
Ano tayo yan, Sid?